All right, so we are picking up with finding reference angles. So we have to sketch the angle and then find its reference angle, which basically just means find the acute angle that is made with the x-axis and tell like what it is, essentially. So something like number 16, it is negative 100 degrees. So I always draw a little tiny graph to put to plot it on, put where it is. So negative 100 degrees would be just a little bit past 90. So the angle itself would be about right here. Now, there should have been some formulas in your notes for these. Should have been something like 180 minus theta for quadrant 2, theta minus 180 for quadrant 3, and 360 minus theta for quadrant 4. Should have been titled like reference angle relationships or something like that.
Oh, yeah.
Those are the formulas that we're using. Anyways, so when we do that though, we need to look at the positive angle, not the negative angle. So what would this angle be if this was negative 100?
260 degrees.
Yep, 260 degrees. So this is theta, and theta is 260 degrees. But what I care about is from the x-axis to the red angle. That's my reference angle. So your reference angle is going to be acute. So this is what we call theta prime. So theta prime is what I'm solving for. Now, it's in quadrant 3, so we use theta minus 180. This is why we had to change it to positive, because if we use the negative one, it's not going to come out correctly. So we have to use the positive angle. So then we just plug in 260. So 260 minus 180 is 80 degrees. Now, I'm going to be completely honest with one like this. If you can just figure out, like, this was 10 past, that means 90 minus 10, I'm okay with that. If you can just see it. A lot of times these formulas, people just get really confused when, quite frankly, they know the answer. So if you know what it is, like, that's fine. Let's see. 18. So this one is 320 degrees, so it's already given to us to be a positive angle. So what quadrant does 320 degrees fall in?
4.
Quadrant 4. So we have this angle goes all the way around 320 somewhere in this general area here. So this is my theta. I care about theta prime, which is what connects it with the x-axis. And this is one of those things, if you want to use like colors so you can see the two different, I'm more than okay with that. So what is the formula for quadrant 4 for theta prime?
360 minus theta.
360 minus theta. So 360 minus 320. So theta prime is 40 degrees. And if you just memorize the degree formulas, the radian formulas are the same. It's just replacing 360 with 2 pi, 180 with pi, things like that. So looking at a radian 1, number 20, negative 5 pi over 6. So where does that fall?
Quadrant 3.
3. So it's going to go back this way.
Oh.
Because 6 pi over 6 would be, just pi, which would be over here.
Yeah.
So we have, that's going to be somewhere over here. Which is theta. So remember, this is a negative value. I need the positive value. So what would my positive theta value be?
7 pi over 6.
Yep, 7 pi over 6. So theta is 7 pi over 6. So I care about this area here between the x-axis and my angle. So what is the formula for quadrant 3 for a radian value? Theta prime is equal to what?
Theta minus pi.
Yep, theta minus pi. So theta was 7 pi over 6. Now, obviously, I would need a common denominator so to subtract. So you can just rewrite it as 6 pi over 6 because that's still pi. So 7 pi over 6 minus 6 pi over 6 is just pi over 6. So theta prime is pi over 6. All right, let's do one more just because it's a little bit different in what it is. So 22, 15 pi over 4. So this one is a positive angle, okay? But it's bigger than 2 pi. So when we're going to do this, we need to get it down to whatever the value is that is less than 2 pi, or it's going to not give us a reference angle. It's going to give us something that's bigger than an acute angle. So we can go around and see where it is, but so we have, let's see, 4 pi over 4, 8 pi over 4. Oh, no, stop that. So we're at 8 pi over 4, 12 pi over 4, 13 pi over 4, 14 pi over 4. So 15 pi over 4 is down here. I care about this theta value in here, theta prime. So we went around one full time, and then how much more did we go around after that?
7/8 of the way out. Or 7 pi over 4.
Yep, 7 pi over 4. So my new theta value is 7 pi over 4. Because basically now all I care about is this second partial time that I went around.
How did you get that? I'm confused on that. How did you get 7 pi over 4?
Okay, so I went around one full time, which would be 8 pi over 4, which is equivalent to 2 pi. And then I was like, okay, well, how much farther around did I go? Another way you could do this is you could find a coterminal angle. So you could go back to what we were doing before and just subtract off 2 pi from this. So you could do 15 pi over 4 minus, and then 8 pi over 4 without ever having to graph it. And then that would give you 7 pi over 4. It would be a coterminal angle that falls in the same spot, because this angle that we went around the first time and this angle are all the same.
Okay.
So no matter how you look at it, like 7 pi over 4 is going to hit the same as 15 pi over 4, and the same as if you added 8, like what, 23 pi over 4? It's going to keep hitting in the same spot. So you can just find the coterminal angle, which is essentially all we're doing here to begin with. It's what we're doing with the negative angle when we're given one. And then we're going to use that value because we basically need the least positive value, the one that's less than 2 pi, or in the case of degrees, less than 360 degrees to be able to solve it. Or your answer is going to be something bigger than an acute angle.
So could I do like the coterminal thing, like subtract
Yeah.
2 pi for any of the radian ones? Like
If the original number, so like 15 pi over 4, if it's bigger than 2 pi, yes.
Okay.
Yeah, or bigger than 360, same thing. Honestly, I show the drawing way because it's the way the book does it, but I do think the coterminal way is easier. The only advantage to doing the drawing is that you know exactly what quadrant it's in for the purpose of using a formula. But again, like if you know anything about like your unit circle, because in summer text they're expecting that I haven't taught the unit circle yet.
Yeah.
And so like if you know anything about it, you'll know, well, there's 90 degrees in here, so if I'm taking, or pi over 2 in here, so if I'm taking off, whatever, like I can just subtract and find it without really using the formula.
Yeah.
So what is the formula for quadrant 4 for radians?
Theta prime equals 2 pi minus theta.
2 pi minus theta. So again, theta is 7 pi over 4, so it's going to be minus 7 pi over 4. 2 pi, I'm going to rewrite as a pi over 4 value, so it's going to be 8 pi over 4. So then theta prime ends up just being pi over 4. So any other questions about those ones? This is probably the most difficult thing in this section, just because people don't understand how to draw it. So like I do think the coterminal is a little bit easier. It's like find the coterminal angle, then draw it is probably the best way to do it, to be completely honest. But all right, the next stuff you're going to need to have your unit circle handy. It says to evaluate the function without using a calculator. So I'm probably going to, I'll work through several of these just so that we can talk about them. Again, if it's like the sine, cosine, or tangent of a value, those values are all coming straight off of the unit circle. Cosine is the x values, sine is the y values, tangent are those values that we put outside the parentheses already solved out for you. Oh, that's not the right button. I'm trying to focus it in a little bit. But a lot of these questions are going to be, what is it when it's secant, cosecant, or cotangent? Like, how do we find that? So 24 starts out with the secant of 135 degrees. So that's not a value that's on there, directly on your unit circle, but 135 degrees is on your unit circle. So, what other trig function goes with secant?
Cosine.
Cosine. What is the relationship of cosine and secant? Like if you were given the cosine value, what would you do to find the secant value?
Flip it.
Flip it, okay? So secant is the same thing as 1 over cosine. So it'll be 1 over the cosine of 135. Now, these are without your calculator, but let's say you ever were to check them, make sure you pay attention to if your calculator's in degree or radian mode, because this is, it will make a difference for these problems. So,
These ones we would have them in degree, right? before we
Right, yeah. These ones technically say without a calculator, so like if you go give me a decimal value, I'm going to use your calculator,
Yeah.
basically. But that being said, you will have your calculator. So if you choose to check the value afterwards, like say it comes out to be the square root of 2 over 2, then you could just do on your calculator, okay, what is the square root of 2 over 2 in a decimal form, which we kind of mentioned it the other day when we were doing it, but say, okay, what is that? Put it in, but you have to type it in this way because there's not a secant button on your calculator. So I'm looking for the cosine of 135 degrees. So I go around, I didn't even realize. So cosine is the x value, so it's minus root 2 over 2. So I'm going to have, this is 1 over minus the square root of 2 over 2. If we divide by a fraction, it's the same thing as doing what?
Multiply.
By what? Or you can give the little acronym that my mom says and I think Miss Holloway says. Keep,
change flip.
keep, change, flip. So keep the top. We change the sign to multiplication and we flip the fraction. So it'll be, since it's just 1, I'm just going to flip it to be minus 2 over the square root of 2. But we can't leave it that way. So we have to multiply by the square root of 2 over 2. Now I'm just going to show these steps out really quick just because, but just know that you don't actually have to show this every time. So this is going to be, ends up being minus 2 square root of 2 over 2, which is just going to reduce to minus the square root of 2. But you could have gone straight from here to here if you saw it and wanted to do that.
We multiplied by square root of 2 over square root of 2 because we can't have a square at the bottom.
Correct.
Okay.
Yep. Um, 26. Sine of negative 150 degrees. So there's two ways you can think about this. Obviously, we don't have negative angles written on our unit circle, and that's okay. You can go around until you find where the negative one is, or you can change it to a positive angle by finding one of its coterminal angles by adding 360. I'm going to show you both ways what it would look like. So we have minus 150, so that means we come down and we go in reverse. So we know to here is minus 90. So how much more do I need to go? So 150 minus 90 is 60. So I need to go 60 more degrees. So this would be 30, 45, 60. So I'm looking at minus 150 is the same as 210 degrees. So you can think about this as the sine of minus 150, or you can think about it as the sine of 210 degrees. Either way is fine. And to do that, you also could have just added 360 to see, that it was 210. So then we look at the sine value of that. So the sine value of 210 is negative 1/2. And so your answer for that one is just negative 1/2. All right, just for the sake of some stuff that I want you to see, I am going to end up doing a couple odd ones, just because I want to go over some stuff with those. So 27 is the cosecant of minus 420 degrees. So cosecant, obviously not on our unit circle, but what other trig function has a relationship, and what is the relationship?
Sine.
Sine, and what is the relationship? Flip it, yeah. So 1 over sine of negative 420 degrees. Now, we could either go on the unit circle and find it. Since it's bigger than one full time around the unit circle, I would say at a minimum, add 360 once to find a smaller negative angle that I can see, or you can add it twice to find its positive angle. So I'm going to do that method for this one. So 420 minus 360, which is obviously me adding 360 degrees to get to the next negative angle. So this is still going to be negative. So that's negative 60 degrees. So you can either now treat this as 1 over the sine of negative 60 degrees, or you're welcome to add another 360 and get the positive angle, which you could then treat as 1 over, well, negative 60 plus 360 is going to be 300. So you can treat this as the sine of 300 degrees. So you can look at it however you want. If you're comfortable with just drawing all the way around the unit circle until you get back to negative 420 degrees, completely fine. I'm not expecting you to like draw like you're going around or whatever, how you get there. I would say if you are going to change it, at least write what you're changing it to. Because as a general rule with these problems, I don't necessarily expect a lot of work to be shown because you're reading values off the unit circle. But if you're going to change it, I would say tell me what you're changing it to, because if for some reason you add or subtract wrong, then I'm like, okay, it's not so much they didn't know what they were doing, it's just that like there was an adding or subtracting mistake. Because if we're being honest, that's where most of my math mistakes happen, is in adding and subtracting. So then we can go over to our best friend. And so we can go to the sine of, we said it was 300, right? Sine of 300 degrees, which would be negative root 3 over 2. We could have started here, worked backwards, minus 60, but again, it hits in the same place, so negative root 3 over 2. But remember, it's 1 over, so this is 1 over square root of 3 over 2. It's the y value, so it's negative also. I think I said that, but don't forget that part. So keep, change, flip, so this is going to end up being minus 2 over the square root of 3. So then we multiply by the square root of 3 over 3, which is going to end up giving us minus 2 square root of 3 over 3. All right, I want to look at 29 because it's pretty different from what we've been doing, and I'm going to kind of show you two ways to think about this problem as well. Cotangent of minus 8 pi over 3. So, cotangent goes with what? Or like, what's its trig function that it goes with? Tangent. So it would be 1 over tangent. So one way we can think about this is 1 over the tangent of minus 8 pi over 3. And obviously we can, since that's bigger than 2 pi, we can convert it to be, you know what I'm trying to say, the least negative angle or the first positive one. So we can do that. But another thing is tangent is equal to sine over cosine. So cotangent, because it's flipped, is equal to cosine over sine. So let's say that this is where I wanted to bring up. So the values that we have on here for tangents, you don't necessarily even have to memorize them. Now, if you do, that's great. But all you have to do to find the tangent values is divide your y by your x. So, for example, with this first one at 30 degrees, you have 1/2 divided by the square root of 3 over 2. So if you divide that, you flip it, so you'd have 1/2 times 2 over the square root of 3, and then 2's cancel, and then, 2's cancel, and then you're left with 1 over the square root of 3, and then we rationalize it to root 3 over 3. So if you forget what they are, you can do y divided by x in every case, and then you can find them. So it's like if you know your sine and cosine values, or your x and your y values, no reason you can't find your tangent values. So if you're like, this is overwhelming to memorize, nothing wrong with, you can have an extra sheet of paper when you take it, and then you can just do the math. Yes, it takes a little bit longer, but if you're struggling to memorize it, that's an option. So I'm going to convert this angle, especially because it's in radians, to something else. So I'm going to find the coterminal angle. So negative 8 pi over 3. So I'm going to add 6 pi over 3 because that's 2 pi. So that gives me negative 2 pi over 3, which I could just go to my unit circle and find that value if you want, or I can go ahead and find the positive one, so I can add another 6 pi over 3, which is 4 pi over 3. So now I'm going to treat this as 1 over the tangent of 4 pi over 3. So the tangent of 4 pi over 3 is down here, and it is the square root of 3. So this is going to be equal to 1 over the square root of 3, but that's a problem. We have to multiply by the square root of 3 over 3. Square root of 3 over square root of 3, which gives you square root of 3 over 3 for your answer. Now, if we back up, let's say that we didn't do it as 1 over tangent. I'm going to show you the way of doing cosine over sine in this case, just so that you see it and that it does give you the same answer. So I'm going to leave it as cotangent. Now, I am going to use the modified 4 pi over 3. So cotangent is equal to cosine of 4 pi over 3 divided by the sine of 4 pi over 3. So from my unit circle, cosine of 4 pi over 3 is negative 1/2. So I end up with negative 1/2 divided by sine is negative root 3 over 2. So now you have two fractions. You divide by or multiply by the reciprocal. So you have negative 1/2 times negative 2 over the square root of 3. 2's cancel, negatives cancel, and then you end up with 1 over the square root of 3, which ends up being the square root of 3 over 3. So both ways work. A lot of people like to go with the first method that I did, to be completely honest, but I wanted to show you the other way in case you're like, I don't remember. And there's going to be some things where it's easier to do, cosine over sine or sine over cosine, just depending. So that way you have both. Any questions about any of these ones? All right. So where did I stop giving you problems yesterday? Did I give you problems yesterday? Yeah, I did. Okay, so I gave you through 15 yesterday. So then to add on to that, you're going to have 17, 19, 23, 25, and 31.